Welcome back, coders. You are watching top trending open source GitHub projects this week. Part 1, where we dive deep into 10 game-changing repositories. Today we're exploring projects that redefine AI development. We'll look at Stagehand for smart browser automation that mixes AI and code, and the lightweight MCP-based Chatbot COG SP32. Discover tiny recursive models, TRM, proving small models can deliver big reasoning power. We also cover ZAG for framework-agnostic UI logic and essential debugging tools. Get ready to upgrade your tech stack.
Welcome back to Manu AGI Tutorials. Here, we explore the exciting world of AI, latest AI tools for you, so don't forget to hit that subscribe button and the notification bell so you don't miss out on the latest AI insights. So let's start today's video.
Project number 1, Stagehand. The AI browser automation framework that blends code and intelligence. Stagehand is unique because it sits in that sweet spot between rigid script-based automation and full AI agents. It gives you both precision and flexibility. Traditional browser automation tools are brittle. If the website layout shifts, the whole thing breaks. On the flip side, full AI agents promise autonomy, but often act unpredictably or opaque. Stagehand strikes a balance, letting you mix human-style natural language commands with deterministic actions to get both control and adaptability. The heart of Stagehand lies in 4 core capabilities: act, extract, observe, and agent. These allow you to direct interactions, pull structured data, explore possible actions on a page, or defer to a higher-level agent that sequences tasks intelligently. You decide how much AI you want in the loop. Because of that, your automation stays more stable in real-world conditions, a mixture of code where you know exactly what must happen, and AI where flexibility is needed. Another standout is how Stagehand supports previewing and caching actions. Before executing anything, the system lets you review how the AI would act. For common or repeatable tasks, it can cache those actions, so you don't incur extra cost or risk with the AI model each time. It also supports self-healing. When the UI changes or elements shift, Stagehand can adapt by re-evaluating context instead of failing outright. Because Stagehand is fully compatible with Playwright, you never lose access to low-level control. You can layer Stagehand on top of existing scripts, applying it gradually or fully as needed. And because it was built from the ground up for AI-native workflows, it's optimized for speed, cost efficiency, and reliability in AI-powered browser tasks. In summary, Stagehand is unique because it gives you the best of both worlds. Script-level accuracy with agent-level flexibility. It adapts to change, lets you mix AI and code, caches smart actions, previews behavior, supports self-healing, and stays compatible with existing tools. If you need dependable, adaptable browser automation today, this is one of the strongest bridges between classical automation and the AI future. Before we move to the next project, I've got something really cool for all the creators who love building with AI, especially if you're into video generation. I recently created 100+ AI ads JSON prompts for Veo-3, a complete prompt library that helps you generate cinematic brand-style ads for companies like Tesla, Apple, Nike, Dior, and many more. These prompts are designed for anyone who wants to make high-quality AI video ads, whether you're a beginner or already creating content. And here's the best part. All my YouTube Premium members get this list absolutely free. But if you're one of my regular YouTube followers, don't worry, you can grab it through the link in the description. It's the same prompt pack I use to create some of the most creative Veo-3 ad videos you've seen on this channel. Go check it out, download it, and start creating your own cinematic AI ads today. Alright, let's jump into our next GitHub project. Project number 2, MCP-based Chatbot. A pocket AI chatbot on ESP32 via MCP. Xiaoji.esp32 is remarkable because it brings AI voice chat capabilities into ultra-compact hardware, letting you build your own AI friend using an ESP32 module. What makes it stand out is how it combines advanced AI interactions with low-cost electronics, bridging the gap between large language models and physical devices. Instead of relying on heavy local processing, Xiaoji.esp32 connects to remote AI services through protocols like WebSocket and UDP. That means the device doesn't need to run a full model itself, yet it supports real-time voice interaction, multi-turn conversations, and even wake word detection. It supports multiple languages, Chinese, English, Japanese, Korean, and offers flexibility in voice tone, recognition, and prompt customization, adding personality and making conversations feel more natural. Another standout is its use of MCP, Model Context Protocol, as a control channel. In newer releases, MCP is the default protocol for managing context, streaming, and control signals between the ESP32 and backend AI systems. This setup helps maintain stateful conversations and lets the hardware stay lightweight while still keeping track of memory, context, and turn history. That's rare for a small embedded device. Xiaoji DSP32 also supports camera functionality and extended hardware compatibility. Some versions allow the ESP32 to take photos, incorporate a visual context into conversations, or trigger responses based on images. Over time, it's scaled support to many ESP32 variants, improving wake word support, bug fixes, and better integration of components. In summary, what makes Xiaoji DSP32 unique is how it marries AI conversational power with minimal hardware. It uses remote AI models, MCP for context control, supports multilingual voice, and brings the magic of chatbots into compact IoT devices. For anyone who wants a smart voice interactive gadget that feels alive yet runs on simple electronics, Xiaoji DSP32 is pushing the boundaries. Project number 3, Tiny Recursive Models. Small model, big reasoning power. Tiny Recursive Models, TRM, is redefining efficiency in reasoning AI by showing that less can be more. What makes TRM unique is that it ditches complexity and scale, and instead leans into recursion and refinement to solve tough reasoning tasks, even surpassing much larger models. Built by Samsung's Sale Montreal team, TRM works with just 7 million parameters, yet it competes with or even beats giant language models on benchmarks like Sudoku, Maze, and ArcAGI. The core idea is surprisingly simple but powerful. TRM starts with an input question, an initial guess for the answer, and a latent reasoning state. Then it repeatedly goes into think mode. It updates the reasoning state based on the current input and guess, then improves the guess using that reasoning. Over multiple passes, it hones the answer step by step, correcting mistakes and refining its output. It doesn't rely on heavy hierarchies or multiple networks. Everything happens in one compact loop. That's where TRM truly breaks convention. Traditional reasoning models often build multiple cooperating components, complex supervision methods, or expensive recursion frameworks. TRM strips all that down. It avoids fixed-point mathematics, biological metaphors, and heavy architectural layering. It uses a single network looping over reasoning steps, but yields results that rival or exceed many large resource-hungry models. Its performance is stunning. On Sudoku Extreme, TRM jumps accuracy from 65%, typical for prior models, to 87%. On Maze Hard, it reaches 85%. On ArcAGI 1, it hits 55%, and hit percent on ArcAGI 2, beating out many LLMs built on orders of magnitude more parameters. Those gains show that strategic computation and recursion can outperform brute scale when applied smartly. In a world obsessed with massive models, TRM reminds us there's elegance in restraint. It's not about how many parameters you have, but how intelligently you use them. TRM proves you can do advanced reasoning with tiny networks by thinking again and again, refining toward clarity. Project number 4, ZAG, State Machine-Driven UI Toolkit for any framework. ZAG is unique because it separates component logic from presentation, using state machines under the hood. Instead of rebuilding the same interactive behavior over and over for each framework, it allows you to define how a component behaves once and reuse that across React, Vue, Solid, or others. What makes ZAG special is its framework-agnostic core. The logic for interactions, like focus management, keyboard handling, opening or closing menus, selecting items, and more, is defined in a machine's layer. That means the behavior is predictable, testable, and consistent no matter which UI framework you use. On top of that, ZAG provides adapters, connectors, to link that logic to the DOM in a way that respects accessibility, area roles, keyboard navigation, focus traps. Another standout feature is that the logic is unstyled and headless. You control how it looks. ZAG doesn't impose a visual style or CSS system. You get the pure behavior, and you plug in your own styling solution. This is powerful because it avoids visual lock-in. Want it to look like Material, or Tailwind, or your own design? You decide. ZAG is also built with accessibility as a priority. It handles tricky details automatically, such as managing focus, keyboard events, and ARIA attributes, so you don't have to reinvent those parts in each component. Because it's modular, you can adopt parts of ZAG gradually. You don't need to rebuild your whole UI at once. Each component's logic is its own package. You can pick and choose which machines to use. Zag is also one of the foundations for Chakra's future ecosystem. Chakra's new architecture weaves in Zag and its state machine model to provide more robust, maintainable behavior for their UI components. In summary, Zag isn't just another UI library. Its uniqueness lies in putting behavior first, defining interaction logic once via state machines, making it framework independent, testable, accessible, and styling agnostic. For any component you build, you get consistent, reliable behavior you can plug into whatever visual style you like. Project number 5, ElevenLabs UI, bringing voice creation to life with a simple interface. ElevenLabs UI shines because it turns powerful voice synthesis and control into a beautifully usable interface. It's not just another UI shell, it's the visual gateway to ElevenLabs' rich voice features, letting creators work naturally with speech, tone, and voice styles, without fighting with low-level configurations. What makes it unique is how it balances accessibility and depth. New users can get amazing results out of the box, while advanced users still have fine control over voice settings, modulation, and model choice. At its core, ElevenLabs UI helps you express nuance. It doesn't just convert text to speech. It gives you control over voice character, emotion, pacing, and style through simple visual controls. Want the voice to be calm, energetic, whispery, excited? Instead of writing technical prompts, you adjust sliders or drop-downs. That means your storytelling, narration, or audio branding gets that human touch with minimal friction. Another standout is how it manages complexity behind the scenes. You don't need to know about model IDs, endpoints, or API quirks. The UI hides engineering details behind intuitive panels, real-time previewing, and instant feedback, so you can iterate quickly. This makes voice design feel like working in a creative studio rather than troubleshooting a backend. Because it's tightly integrated with ElevenLabs' voice engine, changes you make in the UI take effect immediately. You hear exactly how edits affect pitch, timbre, and emotion. No long wait. That instant loop between idea and output is rare in voice tools, and it empowers voice makers to experiment freely. In short, ElevenLabs UI is unique because it turns powerful speech models into a friendly, expressive workspace. It bridges artistry and technology. You shape characterful voices by interacting visually, while all the complex AI is running under the hood, ready to respond instantly to your creative decisions. Project number 6, Chrome DevTools MCP, enabling AI agents to control and inspect live browsers. Chrome DevTools MCP is a powerful bridge that lets intelligent agents take full control of and monitor live Chrome browsers via the Model Context Protocol. What makes this tool uniquely compelling is that it transforms agents from passive prompt processors into interactive browser operators. Using DevTools MCP, an agent can not only open pages, click links, and fill forms, but also dig deep, analyze network activity, capture console logs, trace performance metrics, and debug in real time. What stands out is that it marries automation and inspection in one package. Many tools only let agents automate tasks in the browser, but with Chrome DevTools MCP, your system also gains access to the same diagnostics and insights a developer would see in Chrome DevTools, making agent errors, performance bottlenecks, or unexpected behaviors easier to detect and correct. Because it runs as an MCP server, it standardizes how agents connect, commands flow, and results are streamed, making it easier to plug into AI agent platforms compatible with MCP. Another unique aspect is its use of reliable automation combined with intelligent waiting and sequencing. Rather than firing commands blindly, the tool waits for results or state changes to ensure actions were successful. This makes execution far more stable and less brittle than naive scripts. For instance, when an agent navigates a page, Chrome DevTools MCP can wait until network requests settle, detect console errors, take screenshots, or record a detailed performance trace. This gives you visibility into what the agent actually saw and how the page behaved under its actions. In short, Chrome DevTools MCP stands out by giving AI agents access to the full instrumentation layer of a browser. Agents don't just click buttons, they see what's happening inside the page. This opens the door to smarter web automations, autonomous agents that debug themselves, and workflows where AI can build, test, and optimize in a real browser, all under the same protocol interface. Project number 7, GroupMQ, Redis-backed per group FIFO-Q for Node and TypeScript. GroupMQ sets itself apart by solving a tricky problem many queue systems struggle with, ensuring strict order within each group while still allowing parallel processing across different groups. In simpler terms, if you're handling tasks tied to individual users, accounts, or entities, GroupMQ makes sure tasks belonging to the same group always run in the right order, no mix-ups. yet handles many groups at once for speed. What makes it truly unique is this per-group FIFO guarantee. Traditional queues let you push jobs and process them, but when jobs from the same group run out of order due to timing or concurrency, you can get conflicts or inconsistent state. GroupMQ prevents that by locking a group while it processes one job at a time, only unlocking when it's done, so within a group it's always first in, first out. Meanwhile, different groups don't block each other and can be handled in parallel. Another standout feature is how it orders jobs by timestamp, order EMS. Suppose events from the same group come in with slightly different times. GroupMQ respects those timestamps, arranging jobs accordingly, even compensating for late arrivals, so things stay chronologically consistent. Also, GroupMQ is designed to be lightweight, efficient, and production-ready. It uses fast Lua scripts under the hood, ensuring atomic operations in Redis, no race conditions, no partial failures. It also includes features like delayed jobs, retry strategies, repeat/cron tasks, and built-in cleanup of stalled tasks. What's more, it's compatible with monitoring tools like Bullboard, making it easier to visualize and manage queues. Designed for Node plus TypeScript environments, it serves as a powerful building block for applications where order, concurrency, and correctness all matter. In short, GroupMQ is unique because it blends the strict ordering control needed per group with high throughput across many groups. If your system has group tasks that must never shuffle in the wrong sequence, this tool makes that guarantee while still keeping your performance high. Project number 8, AI SDK DevTools Instant Insight and Debugging Toolkit for AI SDKs. AI SDK DevTools isn't your usual monitoring tool. It's built specifically for real-time visibility into AI interactions. What makes it unique is that it shows you what's happening inside your AI agent workflows, streaming events like tool calls, internal reasoning steps, memory state changes, and performance metrics, all live. Instead of guessing what's going wrong, you can see exactly how your AI is thinking and acting. One standout feature is how deep and granular its introspection goes. It doesn't just surface logs, you get event streams showing call chains, function usage, tool execution, arguments passed, responses returned, latency, and memory snapshots. That means when an AI agent calls an external tool or performs a decision, you can trace that call path in the UI. Because AI agents are often black boxes, DevTools turns them into transparent systems. Another key strength is seamless integration and ease of use. It is designed to plug into your AI setup without major disruption. You don't need to rebuild your architecture. DevTools is built to fit into existing SDKs and pipelines, enabling you to get insight instantly. And because it works with streaming models and tool-based agents, you can follow long conversations or chain tool usage with full context. What truly sets AI SDK DevTools apart is how it helps with performance tuning and debugging in production-level AI systems. When an agent flounders or produces wrong results, you can pinpoint exactly which tool or memory call caused it, or what decision branch it took. This accelerates debugging and improves reliability. It's not just for prototyping or experiments. It's intended for real AI systems that need observability, accountability, and robustness. Altogether, AI SDK DevTools is unique because it gives you full introspection, real-time tracing, granular event data, and smooth integration in one package. It turns your AI workflows from opaque pipelines into transparent, monitorable, accountable processes, and that's a huge advantage when building reliable, production-grade AI applications. Project number 9, OpenAI Apps SDK Examples. Showcase of how to build apps inside chat interfaces. OpenAI Apps SDK Examples is special because it opens up a clear window into how external tools and interfaces can work seamlessly inside a conversation with a language model. This repo doesn't just show snippets, it demonstrates full end-to-end flows combining MCP servers with rich UI components, giving you a living blueprint for how to make apps inside chat feel natural. What makes this project truly stand out is how it weaves together 3 tightly integrated layers. The server side, which advertises and executes tools, the model layer, which reasons about when and how to call tools, and the UI side, which renders interactive widgets in line with text responses. When a tool is called, not just raw text but structured results with metadata, let the interface respond with charts, buttons, or other visual elements, not just bland answers. The use of Model Context Protocol, MCP, is a core differentiator. Through MCP, tool contracts are standardized, tools advertise their inputs/outputs, and optional hints, and responses can include embedded metadata that drives widget rendering. That means developers don't have to reinvent how model, server, and UI communicate. You follow the spec and things just plug in. The examples show how servers in Python or Node can return a mix of plain text, structured JSON, and output templates that the Apps SDK turns into rich UI elements. Moreover, the repository includes a variety of demo tools, like a Pizzazz toolset and a 3D solar system visualizer, that illustrate how flexible and expressive such integrations can get. These demos aren't just for show, they're inspirations you can adapt, swap, or extend to match your own ideas. In short, this project is unique because it brings together tool execution, AI reasoning, and dynamic UI in one unified protocol-driven architecture. It doesn't just tell you what's possible, it gives you working modular examples that you can build on directly. Project number 10, MCP Inspector, Visual Debugging and Testing Tool for MCP Servers. MCP Inspector shines because it gives you a clear window into what's happening inside your Model Context Protocol servers, without you having to dig through log files or blindly guess. Unlike generic debugging tools, it's built specifically for MCP. You get a visual interface to test prompts, list tools, inspect resources, and view server notifications, all in one place. The architecture is clever. There's a front-end client built in React that lets you interact with your server in the browser, and a back-end proxy component that bridges communication across different transport protocols. This proxy isn't a packet sniffer. It functions as a bridge, so your browser UI can talk to an MCP server, whether it communicates over HTTP, SSE, or standard I/O. This design ensures you see everything in real time, no matter how your server is set up. What makes MCP Inspector particularly unique is how it surfaces detailed structure and behavior. You can view every tool your server supports, see prompt templates, explore available resources, and test each of them live. You don't need to run messy terminal commands. Instead, you click around, input sample arguments, and see the response instantly. You can also toggle transports on the fly and change connection settings in the UI. Many developer tools focus only on logging or metrics, but MCP Inspector adds context. You see the semantics, the meaning of each tool, prompt, or resource defined in your server. You can observe real traffic, test error cases, and simulate usage directly from the inspector. Another advantage is accessibility. You can launch Inspector using npx, no heavy install needed, and quickly point it at any MCP server. That speed and low friction make it a go-to tool during development. Plus, if your MCP server evolves or supports new transports, the Inspector proxy can adapt. Its modular transport support means you don't need a new tool for each variation. In essence, MCP Inspector is unique because it offers live, structured, visual exploration of MCP server internals. You don't just debug, you see how your server is built, how tools and prompts behave, and how resources flow, perfect for refining and validating MCP implementations with confidence. That wraps up part 1 of our look at the most exciting projects on GitHub right now. We covered everything from the powerful framework-agnostic UI component toolkit ZAG to ElevenLabs UI and more. If you found your next project in Stagehand or are excited by the deep introspection offered by AI SDK DevTools, give this video a like. Let me know which project you're building with first. Don't forget to subscribe so you don't miss part 2, where we'll explore even more disruptive open source repositories.